Hi and welcome. This time around I've got a little upgrade project. The belt sander project I finished a while ago has turned out to be one of my more useful tools. I use it all the time. I wish I'd had one a lot sooner. One of the things I wish I'd done, just in retrospect, would have been to have this edge pulled in right next to the belt on the side so that you could get around it. One solution I could do would be to remove this top plate, and it would let you get on the side of the belt a little bit up high, but I really didn't design it that way. It would have improved the design a bit, because then you could get parts that wrap around. I discovered that very recently. It still works out fine, but this large flat surface behind it sort of limits you to half circles sort of thing, which is not great. But the improvement I'm going to do this week is only aesthetic. I got these stickers a while ago because I thought it'd be nice, and it isn't bad, but I think I got something that'll improve this look quite a bit. So I'm going to peel this sticker off, and in its place I've got something else that is going to look a little bit better, and I'm kind of excited about it. And my solution to this problem was solved by Thomas Utley of Vaughn Industrial. You've seen his work on some other channels very likely, Keith Rucker, Tom Lipton, a bunch of other people. He's famous for making nameplates, reproduction nameplates for equipment. And I got him to make some plates for me, a pair of them. And I think I will inset these into, or inset one of these into the face of the belt sander, so I have a nicer logo on there, because that thing was a ton of work, and it seems like it deserves to have a really nice logo to go with it. Those plates are 50 thousandths thick, so I think I'd like to have them recessed 50 thousandths so that the surface of them is just flush, or maybe a little bit below that, so that they're less likely to get scratched, something brushing straight across the surface. So we need to take this guy off and mark the center, and then relieve it about 50 thousandths, maybe we'll go 60 thousandths depth in the center. But first I have to address a couple of issues. This plate is bigger than my rotary table, so I can't easily just center this on the rotary table, because I won't easily have a way to clamp it down. I've thought of some interesting clamp designs that I might pursue in the future, but instead I thought, well, let's try boring head. I have a 3-inch boring head that I got used, and it will almost get to the 6-inch diameter circle I need to do with just putting the boring bar over here in the corner. However, it won't quite make it. This is 1 inch off center. That's a 2-inch diameter circle. If you take half of the dovetail and extend it out, if it'll go that far, that's another 1.5 inches. And that'd be 2.5 inches. That'd be a 5-inch diameter circle. Not quite enough for 6-inch. But it does have room for this crossbar that goes through. And so I have this nitride coated bar that I used in the belt sander project, actually, for one of the shafts, and I am going to use it here to make an extension arm for a 1/2-inch boring bar, or a 3/8 inch boring bar that will mount in here and let me do the 6-inch circle. So let's make that next. So all we're going to do is pretty simple. Is we're going to face off the end of the boring bar. We're going to chamfer it to make it nice. We're going to drill and tap down the center for a maybe a 3/8. I'm not quite sure. We're going to drill and tap for a set screw that's going to press on the boring bar, and then we're going to take it over to the mill. We're going to cross drill in the mill and ream for a 3/8 inch boring bar, and hopefully this will serve us okay. Hopefully it won't flex too much. This is shafting material, so it is carbon steel. The outside has been nitride coated, which makes it fit in the bore of the boring head really nicely, so that's a nice plus. You want to see an excellent example of hardness, so can you hear the file bite at the end of this where the nitride coating isn't? Here's some of the nitride coating. Just skates right over it like it's not even there. The inside of this shaft is soft as butter. The outside has obviously been, well, it has nitride coating, but below that I think it's case hardened, because it is much, much harder. It's kind of interesting material. Since there's only room for one set screw in the end, I'm going to shoot for 3/8/16 so I can get more bite. There's regular set screws, and then there's these nylon insert ones and the brass insert ones, and I'm going to go for the brass insert ones. I hope you can see that. These are longer than I'd like, so I'm going to have to order some that are the right length. I'm looking for more like 3/8. I have quarter and I have 3/4, not much in between of the brass tipped ones. But these will hold tight on the boring bar and they won't damage it, because I really don't want them to mar the boring bars and rip them up so that they won't slide through, because I'm going to ream this to make it a very close fit. So we're going to go for 3/8 16. So the 70% thread drill is a 5/16 drill bit. This might be a bit fast. We might have to slow this down. It might get chatter. Oh, actually, it's going very nicely. All right, we're tapped. So we're going to part this guy off, and we're going to take it over the mill, and we're going to center drill and ream for the boring bar itself. I'm going to part this guy off with the bar being longer than it probably needs to be, and here's my reasoning. When this goes through the boring head, sticking out, I'd actually want some weight sticking out the other side, because that'll tend to counterweight what's sticking out this side. So it actually makes a little bit of sense. You don't want too much material, and of course, using one of these is going to be very dangerous, because you're going to have this long arm sticking out. Probably got to use it at fairly low RPM, but we're just going to give it a shot. Getting through the nitride coating was tough. Probably damaged my parting tool, and we're going way too fast apparently for this stuff. So we will just slow it down. Probably need some lube too. The outer part of this, remember I said, is case hardened, and you're seeing that evidence right there. Once I got through that outer maybe 60 thousandths, 50 thousandths, it's going like butter, but pretty tough at first, tough going at first. This is some sort of alloy bar too. I forget what material it's made out of. First off, we have all this glorious nitride coating on here. However, I am going to mill a flat along the entire length of this, and the reason for that is when that boring bar goes inside here, just want to make sure on camera, yep. When that boring bar goes inside here, I want it to locate always with the flat on these tightening screws, and that way, when I want to go perpendicular for the cutter insert, I can guarantee it'll always be perpendicular rather than having to futz with it. This will auto align it. I will lose that beautiful nitride coating, but I think it's worth it. All right, so what I'm planning on doing here is taking this end mill and cutting underneath most of the nitride cutting. It's also not one of my good end mills. It is a hard material end mill that some of the bottom teeth have been damaged on already, that I use for side milling, and this will be mostly side milling. So I don't care if the surface finish is not perfect. And we're going to go down about 50 thousandths and see if that's enough. It looks like that'll be perfect based on the flat I'm getting. So interesting, this material is so hard, it's actually pushing the end mill up in the collet, even though I tightened the daylights out of it. You can tell by the width of the cutting path being different. All right, to get this flat here, to have it consistent along its length with only a couple thousandths difference, required 7 passes, because as the end mill cutter comes around this direction, it's running into the extremely hard nitride coating, which is also curved at an angle like this, which tends to want to deflect the end mill up, right? Because it's coming this way, trying to cut in, and it's pushing it up as it approaches. And that coating is so hard, it puts a ton of force on it. So I don't have a Weldon flat 1/2-inch cutter, and I didn't have a holder for this either for 1/2 inch. I would have had to switch to my 3/4 inch, and all my 3/4 inch carbide cutters are not trash. This one's now totally trash on the bottom. This coating totally destroyed it. It doesn't even feel sharp much to the touch anymore, and it's not a radius cutter, so that's pretty sad and depressing. So we were able to get it here. So next step, we can rotate this 90, referencing off this flat against the back jaw, and drill and ream our hole on this side, which will be for the boring bar. First step is using a carbide end mill to go straight through the nitride coating, and I figure it's a sacrificial end mill. And I had a couple of these small ones that I got in a deal. Very sad though. And it's a center cutting, and it's cutting through it like butter, which is good. It didn't cut through the nitride like butter. It complained. Well, I used it to drill all the way through. I did not expect that to work, to be honest with you. I know from this angle it doesn't look like that went straight through, that I'm actually offset, but I double checked. Wow, that nitride coating sucks. Drill bit's probably gonna be toast too after this, both of them. I've got to imagine the reamer's not gonna like this too much either. That's gonna be very unfortunate. As to the fit, I haven't deburred the edges yet, but boy, that is a bonus fit. That is really nice. So hopefully we'll get enough purchase here. I'm still gonna have to orient this guy appropriately this way. I think it's gonna be rotating this way around. And so I've got to get this angle right, or if you go too far this way, you run into the relief, and if you go this way, you don't hit your cutting edge right. So you still have to get that angle right. It would be nice if I could orient, maybe get one of these and grind a flat into this guy, into the cutter, so that it lined up perfectly every time. I could just use that with this boring bar. But for now, we'll make this work. I'm going to remove the burrs off the edge here. And I was thinking this flat that I put in here, could have done it on the surface grinder, and that would have saved all my tools. So just another thought going forward. To mount the large plate, I took my vise jaws off the inside, mounted them to the outside. It's a nice feature of Kurt vices. It gives it a fairly good flat surface to be mounted on, and the vise jaws will pull from the outside. That's pretty solid. The center, there's only about that much of a gap right here where it's not being supported. So I think we're going to be good. I think there's a lesson there. Should keep the end of your tapping mallet cleaner, because you could mark your surface in an unfortunate way. This is all coming off, so it doesn't really matter, but food for future thought. So the first thing is I'm just going to take an end mill. I'm going to manually remove most of the material inside after I mark my center. So we're just going to clean up. So what we're going to do is we're going to set our depth. We're going to do something approaching 60 thousandths. All right, so here's my boring head. We've got the boring bar located. You can see the flat on this side, which these screws that lock the bar in place align it perfectly vertically. The 3/8 cutter is set. I think I've got it right. The rotation this way, correct, to keep the cutter clearance behind it free. And so we're going to go for depth first, because I've just got to touch off on this bottom material. And then we can slowly walk it in. Probably I'm also going to run this at really slow RPM, about 200 RPM. I don't think you should go a lot faster. There's a lot of weight. And I see the bar sticking on the other side. I actually think is a plus, because it counterbalances this a little bit. You've got this extra material here. This is going to want this to rotate this way, which is a big lever arm, so you got to take light cuts. I'm going to use my Z-axis plunge to cut this out. That might have been a big bite. That was 100 and some thousandths. It is cutting all right though. I'm gonna do a smaller bite next time. See it already getting much rounder. And we're just gonna walk out just a little bit more, like 50 thousandths or less. That was a 200 thousandths pass, I lied. This one will be 50. This doesn't have to be a precision fit. I'm not even sure those round parts are precise. And we are there. And the big reveal. Thank you, Thomas Utley. I think you did a great job. Thanks for watching. Hope to see you next time.